Director in Sri Vijayam Fiber Boards. Has an educational qualification of Bachelor of Engineering at Bharatidasan University, Trichy, and Master of Technology in NIT Trichy, and holds a PhD from IIT Madras. He has built 4 commercial successful patents and 15 conference included publications. He is also a technical advisor for Multimedia University, Malaysia, and Southeastern University of Sri Lanka, as well as Invent Glow Technology Solutions Private Limited, an independent company promoted by NIT Trichy, and consultant for Aditya Birla Science and Technology. He has visited countries like Japan, Singapore, Malaysia, and Sri Lanka for academic purposes. Now, we request the pleasure of your company. We welcome you, sir.
Kindly unmute, sir.
Uh, yes, thank you for the introduction. Good morning to all of you. Can I start the session?
Yes, sir.
The slides are visible now.
Yes, sir. Visible, sir.
Just check whether it's moving.
No, sir.
Slides are not moving.
No, sir. It's not moving. Sir, now it's okay, sir.
Okay. Now
Yes, sir.
is it moving?
Yes, sir. It's moving.
So once again, good morning to all of you, and thank you for the opportunity for the presentation. Today I'm going to talk about the additive manufacturing, both plastic and metal. I'm not going to cover in depth because it will take more than 9 to 10 hours to discuss in detail. I will just cover the overview so that the participants, students and faculty members will get an idea whether they would like to do project or whether they would like to move to this additive manufacturing area in their future. With the myriad of new development, partnerships and applications, the additive manufacturing industry continues to grow. This 3D printing industry is growing in diversity. Many players are entering the market. The companies entering the market as startups and spin-off companies. So if you take recent companies registered in India and also in abroad, most of the companies are startup and spin-off. So what is the market for additive manufacturing? If you look into this particular slide, you can able to see this is not particularly the world data. It is particularly for Asia. So you may aware about the Asian countries. In that, India is not a part. In the picture, you can be able to see which are shown in white color. So this is the estimate given by this Tyson Group company for the year 2020 to 21. But now 22 and 23 is going. So you can just add 20% increase in value of the whatever you are seeing in this slide. What is witnessed here is Singapore, Malaysia, and Thailand account for 80%, and the other countries are 15.5% only. They are entered into this 3D printing market. As far as the India is concerned, we are in less than 15% of the market share throughout the world. In particularly India is concerned, it is still growing. More number of companies are expecting. More foreign companies are interested to set up their factory in India for metal printing as well as plastic printing. Companies from Germany, particularly in Europe, from Germany, France, and England, Australia, and US, they are looking Indian market as their huge potential to sell their machines, not for R&D, to sell their machines. So that as India is the second population in the world, and also during the Corona time also, Indian economy not fallen down. So that is the very good news for us. Because of that, they are planning to set up their industries in India. So what I mean to say from this slide is there is a huge scope for students as well as faculty members. Students can start an industry as a startup. Faculty members can start an industry as a spin-off company or a joint venture with existing companies. So the earlier talk, Professor Vinod from NIT Trichy, in his talk, he explained about Industrial 4.0, and two of the participants, one is Panir Selvam and another one is Umar Ahmed. They raised two questions in the chat box. Mr. Panir Selvam asked importance of support structure in additive manufacturing, and Umar Ahmed, why ABS is used in 3D printing. So for those two questions, you will find answer in my presentation. Just carefully watch what I'm saying. And at the end of the presentation, the attendees will get a knowledge of how to assemble a 3D printer of plastic, how to work on 3D metal printing. I will show many pictures, actual pictures, right? And at this point of time, you are supposed to know what is the difference between 3D printing and additive manufacturing. Many people use additive manufacturing. Many people used to say 3D printing. Both are same, but there is a distinct difference between these two. Of course, 3D printing is a process where object is printed layer by layer. So the thickness may be from micron to mm. So it is fundamentally additive rather than subtractive. So at this point of time, you are supposed to know what is meant by subtractive. I will show you in the coming slides. This ASTM F42 standard, which defines all the additive manufacturing process. If possible, you look into this standard, you will get more idea. If you want to know the difference between these two words, 3D printing and additive manufacturing, for shop and factory floor, they use 3D printing as a word. If you go to the shop or factory floor, they will tell it's a 3D printing machine. If you go for an enterprise or supply chain, they will call it as additive manufacturing. That's all. There is no much difference between. So what are the benefits of 3D printing? Only these four benefits. One is design complexity, and the lead times will get shorter. And again, complex geometrics can be produced, and on-demand production. Say, for example, urgently I required 5 component. If you go for a general machining process, it will take at least 1 or 2 days. If you have a 3D printing machine of any size, if there is an urgent requirement of 5 to 10 components, you can print instead of going for normal production process. So that is the on-demand production. That is the advantage. So this is the ASTM standards, which tells about the additive manufacturing standards. So what are all the standards available? If you look at, you can easily see in general standards, additive manufacturing terminology will be there. What are the tests, how to test the component made with the help of additive manufacturing, what are the safety aspects you need to follow, all those things will be there. And process-wise, whether it is a powder or material extrusion, those things will be discussed. In case of application point of view, whether it is applied for aerospace or automation or medical, whatever it may be, all those things will be there. for every application, separate standards are generated. And finished additive manufacturing parts. Say for many people thinking that once the part printed through additive manufacturing cannot be used for the next process. Immediately you cannot do. You have to go for post-processing, particularly in case of metal additive manufactured component. So what are the post-processing techniques that I will cover? And some of the feedstock materials, like in the case of metal additive manufacturing, what are the types of powder, whether it is tungsten or aluminum, or what kind of powders you can use. Those technology, or in case of polymer 3D printing machine, plastic 3D printing machine, what are the types of polymer or filaments you can use? Those things will be covered. So what is the difference between material removal and subtracting? Just for understanding the basics. In the slide, you can able to see a drilling or milling operation is going on in the first image, and chips coming out. So this is called as subtractive machining. So you are subtracting or you are removing the material from the base material. That's why it is called as subtractive. In case of impeller, you could able to see in the below bottom of the slide. So impeller, it will be of initially forged from round to the required shape, and then it will be machined, and it will be sent for heat treatment. Finally, you will get the impeller, which is used for the turbocharger. So heat treatment and the final machining will give you the final product. If you look at this, it will better give you an understanding additive and subtractive. So there is a big block, you have to remove a certain portion. It is called as subtractive. The same block is built layer by layer. It is called as additive, just for understanding purpose. So about the components that can be printed, like Eiffel Tower or printed hollow ball. These kind of balls is very difficult in case of conventional machining, but through 3D printing it is possible. Even sphere also possible. So that's what you can able to see. And some of the complicated shapes, like snake design, many of the people in Western countries, they used to wear these kind of designs. In India, but particularly when they choose to wear ring design and many complicated. All those complicated shapes I will cover in the metal additive manufacturing part. So some of the components, you could able to see this is inconel material, which is used for exhaust manifold for Porsche motors automobile. The wall thickness is just only 1 mm. This kind of shape is possible only by means of 3D printing, right? So look at this slide and try to answer. My question here is on the right hand side, you could able to see one image where continuous operation is going on. Okay, so what are the operation involved in this? It is just a turning operation. So I hope that department mechatronics is organizing. I hope many of the students may be aware about the turning process. It's a simple process done with the help of a lathe to remove the unwanted material, right? Can you hear any response? Hello? Hello? Hello?
Sir?
Is it audible?
Yes, sir, it's audible, sir.
Slides are moving now?
Yes,
Yeah.
sir, it's moving.
Yeah.
Sorry, sir.
Yeah, thank you. So, if you look at this particular slide, particularly this image, you could able to see all these 8 operations involved. One is facing here it is taper turning, and here it is forming and chamfering here, and the thread at the end, and include boring and drilling, and finally knurling. Knurling not seen here, it will be the final process. So if you want to make a shape of this kind, you have to go for these 8 different operations. But if you have a 3D metal printer with single operation, you can build this shape easily with lead time lower than the conventional process. So that is the biggest advantage of for going for subtractive manufacturing. And just a minute. So thank you. Small disturbance. So if you want to go for manufacturing this by conventional, you have to go for 8 different process. Whereas if you use 3D metal printer, you can go by single process, that is building layer by layer. And one more thing, you have to go for one more additional process, that is post processing. Those things I will cover later. So from the last 10 to 15 minutes, I will just get the focus from the participants. So you should, at this point of time, you are supposed to answer this question: what is 3D printing? So it is just converts your idea into a physical product, right? So it is used for fast prototyping, and it's used to as on date only for small scale production. And it can create complicate or difficult to make products in a simple way. So these are all different shapes, which is additive and subtractive differences I have covered. Yeah. So what are the process steps involved in 3D printing? Say, for example, if you have a 3D printer, you need to first create a model. Say, for example, if you want to make a bottle of drinking water, you have to first draw that bottle in your software, either SolidWorks or any 3-dimensional software, and you have to convert that into a s.stl file. So there is one more software called slicing software. With that software, you have to slice whatever the model you have created into number of pieces. And with the help of additive manufacturing system, that is nothing but the 3D printer, you have to finally print the final product. So this is the step what you want to remember, right? So only these things. 5. One, you have to create a model, then convert it into a .stl file. Then with the help of slicing software, you have to slice that whatever the model you have drawn. And with the help of additive manufacturing system, that is nothing but 3D printer, you can do the final product. So there are 2 types of common filament material which is used is PLA, and one more is ABS. And one of the participants asked a question in the last session for Umar Ahmed, you could able to understand from here. So PLA is nothing but polylactic acid. This will normally it will be of solid state. So this will flow like a liquid at the temperature of 170 to 220. And this is biodegradable plastic, typically made from corn or potatoes. And the highest property is tough and strong. So what is the difficulty here is it will cool very slowly, and it contains very low. We can easily break this PLA, whereas ABS you cannot break easily. And heat resistance also very low. But what are the advantages? This is bioplastic, good for students. So smell will be better if you heat the plastic, and it is non-toxic, and also you can print with high speed, and you will get a good resolution. also, and the shrinkage issues will not happen. And this is mostly ideal for small parts, right? Whereas ABS, it is acrylonitrile butadiene styrene, chemical name. And if you want to extrude this, you have to go for 215 to 250 degrees centigrade. Whereas earlier, you could able to see 170 to 220. You have to go for higher because it is always strong, and this is slightly flexible also, this material, and this is heat resistant advantage. Okay. And the biggest advantage is you can get smooth finish. That is the reason most of the component will be made by ABS, and it solidifies quickly, and it is difficult to break compared to the PLA. And it is for it is highly applicable for mechanical parts like gear or any component which include regular moving status, right? So the problem with this material is this is non-biodegradable. So if you heat, you will get some fumes. That smell will irritate you, and this will deteriorate when you expose to sunlight, right? So this is the basic difference. And this is the 3D printer which we developed in our institution with the help of one industry from Chennai. They supported the board, and we did all the assembly, and we manufactured some of the components like lead screw and this bed and the structures, everything designed by us. And the company who we signed the MOU, they assisted in all the electrical parts, electronics parts. So students who are listening this talk can develop their own 3D printer. Now it is very cheap. Even with 20,000 rupees, if you have, you can develop a small size 3D printer, and you can do your own R&D. So some of the components, what you are seeing here, the headphone holder, and this the second object is used for one common application, are done in this. I'll show you other example. So for those who are listening now, maybe for faculty members and students, I will just give you flavor about what are the components that is involved in this 3D printing machine, so that you can easily buy the component and assemble on your own. Okay. So what you are seeing here is the anatomy, what you have seen earlier, the same thing. You can print any shape. The printer what I have shown is of size 500 by 500 by 500 mm, XYZ it can print. And what is important component of this is one is cooling fan. So where this cooling fan will be located near the tip of the extruder. Okay, it just cools and cure the print, right? And the second one is heat sink fan. This will be located near the extruder, and this will blow the air, hot air, and throw it away to the atmosphere, right? And this is the user interface, what you are seeing here. See, this will give you display about current status of the printing. And this is the SD card. So what I have discussed earlier, first you have to design your idea in a software. Then I told you to convert into .stl file. Once if you done with the help of .stl file, then you have to go for a slicing software where your entire object, what you designed, will be sliced. In slicing means nothing but X, Y, Z coordinates you will get. All those will be saved in a SD card, and that card will be inserted here. So once if you insert here, just press the switch on button, your printing will happen immediately. So there is no need to connect your printer with the computer or laptop. Not required. SD card is enough. So this is a belt or cable which is used for moving the entire head of the nozzle, entire head of the printing head to move XY direction, right? Belt or cable. And this stepper motor, as you all mechatronics, you may know about this for precise movement. This is used, stepper motor, and this is the filament, what you can use. So you can get the filament from 1.75 to 2.85 in the market, and now less than 1 mm also available. You have to select according to the nozzle dia what you are choosing. And this is the lead screw. Okay, lead screw is very much important here, because a slight deviation or a slight movement, extra movement in the lead screw will spoil the entire object. Okay, so I will show you a typical example in the coming slide. We faced such a problem in the lead screw. What happened, instead of moving in micron, it moved in millimeter. Say, for example, if I want to move the bed 0.5 micron, it moved 1 micron. So what happened because of that, the entire product building layer by layer get collapsed. I will show you that also. So this is a power supply, which is CL, entire unit. And this is the hot end where the nozzle is entered. So this is a heat sink fan. This will remove the excess heat from this portion. So this one is the nozzle. So wire will come, whether it is PLA or ABS, wire will come through this direction, and it will move from here. Here, at least it will be on solid state. When it comes out, it will be of liquid state. Okay. So in order to record the temperature, what is the existing temperature, thermocouple can be inserted. So this is the in slicing, what is happening, you have to understand first. Say, for example, one of the students designed a structure like this in SolidWorks. So with the help of slicing software, you have to slice this into how many number you have to slice. It depends upon your software will tell you. If you want more precise component to be manufactured, you have to go for maximum slicing, right? Say, for example, this product, this design got sliced. Say, for example, 1, 2, 3, 4, 5, 6, up to here 6. It may be 5, 6, 30 or 35 slices. It may be. So in every slice, you will get one information. What is that? X, Y, and Z. So the X, Y, and Z value of the first sliced component will be definitely different from the second one. Definitely it will be different from third one. See, for example, it is slightly increasing. Okay, so the XYZ value is totally different. So each XYZ value will be stored, and it will be given as a information to the 3D printer. So the printer will print first this slice. Okay, so printer will first print the number 1 sliced component, which is in the bottom here. Okay, XYZ, whatever the value you are it got from the software, it will print, and the next printing will be done here. So this is stage by stage. That is why it is called as additive manufacturing. It will add, right? So most commonly used software is Cura. Now many software comes in the market. So what this slicing software do? It will convert your sliced model into a layer. It will convert your model into a layer by layer, and it will generate a G code. G code is nothing but X, Y, and Z value. This G code will give information to the 3D printer. It will teach the 3D printer, go X this much distance, go Y much this much distance, go Z this much distance. Okay. So that is those information 3D printer will get from the G code, right? So if you look at this image, these two images, you could able to see 2 owls, and I have shown here the list of slicing software available, and some of the softwares are free software. You can download and use also. No need to buy from any company. If you look at these two, I'm not recommending any software here. just for the comparison. So these two are all, by looking, you can easily find. The first one was sliced with the help of Slice 3R software. The second one is sliced with the help of Cura software. So if you look at these two images, which one is perfect? So you have to watch very closely, and you have to decide which one is perfect. So in all, what you can expect is eye. Eye should be extensively visible. You could able to see, if you compare Slice 3R, Cura is better. You could able to see the eye. The same thing also here, maybe due to some poor lighting, it may be different. But comparatively, Slice CR, I'm not recommending Cura is better than Slice CR. Comparatively, it is better. Okay, you can. So then you have to work with 2-3 softwares to get hands-on experience. So once if you use 2-3 software, you will get your experience, own experience. You can choose. But many 3D printer suppliers now, they are selling this slicing software along with their product. So no need to worry about this. So, this is one Octoprint slicing software. In the slicing software, you will exactly know which is printing some gear. If you at any point of time, you could able to see what is the level of printing happening. That is X, Y, Z value. How much X value printed, how much Y value printed, how much Z value printed, how much time is remaining to complete the product. Those information also you will get from this software. So this is the common firmware which is used in the 3D printer. Any student willing to assemble their own, they can go for this. Okay, this is a Merlin, is a firmware which is used Arduino as a platform. Being a mechatronics, you may aware about all these things, or you can consult any of your faculty member. They can also help. So this 3D printing is also helpful in dental applications and also for jewelry applications. And especially for this jewelry, I will just concentrate. And some of the jewelry, famous jewelry in Tamil Nadu, Lalita Jewelry and other companies are using this 3D printing technology to design their product. Say, for example, if you have a complicated shape, you just draw in your software and give this to the Lalita Jewelry, and their technical team will capture your image, and they will make the necessary changes. And finally, you whatever the required shape will be given to you. Maybe if you want a ring, it will be given as a ring, or if you want a chain, it will be given as a chain, whatever it may be. So what is the advantage of 3D printing in jewelry is unimagined freedom of design. You can design any kind of, see from this image, this source from formula, any design, complicated design can be printed. So no need to worry about the weight. Okay, lightweight, because technology like selective laser sintering or jet fusion, which works with plastic powder to make lighter weight. And new level of quality can be achieved with the help of 3D printer. And innovative 3D materials like brass, bronze, or silver. Now, most of the people are using gold or silver or this platinum. They are using as a jewelry made, and even you can try with brass or bronze also. Okay, so it is very easy to manufacture 3D printer jewelry with the help of mold. What we are seeing is the mold, right? So this is one of the project which is ongoing in our laboratory, and with the help of electronics and communication department at EEEE. Being a mechatronics, you can also try similar products. If you just ask after assemble, I'm just concentrating here only on the 3D printed part. I'm not going deep into the electronics part, right? So the electronic, what is the general idea is, if they give some instruction, just to close your finger and forefinger and the middle finger, it will close. Just move or twist your hand, it will twist. Okay, all those things printed with the help of 3D printer. Not done in our lab, it was done outside. And you can also robot arms and other component also you can easily do and assemble. Instead of purchasing, being a student, you can a group of members, 5 or 6 members can join, and they can develop small component with the help of 3D printer. So this is what you are seeing is the Mahabalipuram temple structure. Recently, this was given to the Chief Minister during the inauguration program of Tamil Nadu Center of Excellence in Manufacturing in Tidal Park. And you can see here a complicated and difficult structure can also be 3D printed with the help of this machine. Only thing is, you need to have a very big bed size of 500 or 1000 by mm. Okay. So I will just conclude my phase 1, that is plastic 3D printing. So what you have learned so far, I have just briefed you about the fundamentals between the 3D printing and additive manufacturing and subtractive manufacturing. And I have given some awareness about what are the components or anatomy of the 3D printer, so that by having this knowledge, instead of buying a 3D printer from the market, you can assemble your own 3D printer. Okay. So I'm not going very deep into other terminology because of the lack of time, and also it will not be an interesting session also. So with this, I close the session 1, and the part 2, I will concentrate on metal 3D printing, right? So if you look at the additive manufacturing, there are they will generally classify into 7 types. One is wet photopolymerization and material jetting, binder jetting, material extrusion. In that extrusion, fused deposition modeling and fused filament fabrication. So whatever you have seen earlier is a fused deposition modeling. It is nothing but material extrusion. Material extrusion is nothing but material, solid material will be extruded as a molten material with the help of a heating element. That's all, with the help of a nozzle. So powder bed fusion. In that powder bed fusion, there comes selective laser sintering and direct metal laser sintering. And the 6th one will be sheet lamination. 7th one will be directed energy deposition. So these are all 7 categories available. And I am going to concentrate only on selective laser sintering process on powder based. Okay. Each one single process will take a minimum of 2 hours. Just to attract the listeners, I'm concentrating only on selective laser melting process where powder is being used. Okay. Yeah. So this is the 3D printer machine of EOS. This is the famous machine of model M290, which is available. If you look at any laboratory in India, almost 60% of the users use this machine particularly from EOS company, because this EOS is from Germany. They are the first who entered the Indian market and captured the market. That is why the machines are now available. Now, GE machines are available in the market, and their performance and many competitors also reached in India, and they are trying to, and even there is one Intech DMLS group in Bangalore. They manufactured their own metal 3D printer under Make in India scheme. It is a proud moment for all of us. We have, being an Indian, we have also developed successfully a 3D printer of small size, which with the computer, which is available on the right hand side, and you can control the machine using the option available monitor. Okay, and inside this only printing will happen. How it looks inside, it is shown in the picture too. Inside it will be a chamber which will be controlled by organ or any atmosphere. Okay, when you are doing printing, you have to use argon as a gas, right? So what is the technical at this point of time? This technical data is enough. So this particular 3D printer can build 250 by 325 mm. Okay. So laser used is fiber laser of 400 watts, and the scanning speed is 7 meter per second. That is how fast it can move. That scanning also like so you want to supply the yeah, this chamber, what you have seen, you could able to see here. This is called a slider, and this portion is slider. This will move. This portion is called a slider. This will move this way, and along X direction it will move. So what is happening when moving? I have shown you here. So there will be 2 to 3 chamber, and here for the sake of understanding, I have given only 2 chamber. So what is the general principle behind this is, as I already told, a powder will be used for this additive manufacturing process. In the powder, laser will be passed. So wherever laser moved, that portion will be solidified. That's all. Very simple technology. Say, for example, in the right hand side, you could able to see a shape where laser will move on this particular dimension or shape only. So that wherever the laser moved, that particular area will be solidified. Other area will be only powder. So that is the beauty of this. So as we discussed, it is a process of building layer by layer. Okay, so you cannot build a 3D printer like how we are building our building, putting one brick over other brick. So first, how we construct our wall, we will first put a brick, and then cement, and then again block, and then cement, again block. It will not be like that. Instead of that, it will go reverse. Okay, how the top portion or the bottom portion will be printed first, and this portion will go down, and again powder will be filled. Again, the second portion will be exposed to laser. Second layer will be built. Like that, it continues. Okay. So once this shape got exposed to laser beam, this portion will move down. This portion contains powder. This will move up. Okay. So for the next building, you need powder, no? So for that, this leveling roller will move the excess amount of powder to this portion, so that the entire portion will be covered by powder now. Again, laser will be moved. This process gets repeated. So some of you may not understand what I told. There will be a little confusion. So you could be able to get a better understanding from this image. So there are 3 pistons. So your entire object will be made here. As I told, powder will be filled first in these 2 chambers. Laser will be exposed. So wherever the laser passed, that portion will be exposed that portion will be solidified. Once solidified, this portion will move down. Say, for example, 1 mm, this will move down. This portion will move 1 mm up. So that 1 mm amount of powder will go above the chamber level, and the excess powder will be moved with the help of a leveling roller, so that this excess powder will be covered in the entire area. Again, laser will be focused. Again, solidification will happen. So second layer will form. For those who are not understand in the above picture also, you can understand from here. This is stage 1, where there are 2 cylinders. From this cylinder, some amount of powder will be up. For example, 2 mm. Say, for example, 2 mm. It will not be like 2 mm. It will be of micron only. Micron level only in 3D printer. Just for example, I am discussing. So 2 mm this piston moved. So what will happen? There will be some amount of powder will be in this area. So this is nothing but what you have seen here, roller or scrubber. People will discuss in different name. Just for example, for understanding purpose, I'm showing here. So in the next picture, you could able to see. Carefully listen here. There are 2 pistons. One is here, and another one is here. So this piston is engaged parallel to the bottom. Okay. So when this portion is moving, so whatever the powder here, this will move and take to this portion, and it will level. Okay. That is what you are seeing in here in stage 2. So the piston here, after 2 cylinder, moved to this place. Just moving the excess amount of powder to the and spraying or leveling in the adjacent area. See, it is getting level. So once it is over, the next you could able to see that piston will move up, the other piston will come down. And whatever the excess powder, this will move. So it is initially here. Okay. And it will be moved. Stage 3 will be this moving the excess powder, and it will be collected in the second container. Okay. And again, the process will continue. So once the powder filled, the laser light will pass and solidification will happen. So carefully listen here. Actually, here what you are seeing is 3 chamber only. 1, 2, 3. So this portion is 1 chamber, 2nd chamber, and 3rd chamber. So whatever the excess material in this chamber, that will be flattened to this level, and it will be leveled in stage 2, and it will be filled as you see here. And stage 3, again the excess will be sent to the empty container, stage 3. After that, laser light will pass, material will get exposed to the laser light, solidification will happen. So this is once this happens, inside you could able to see only the material will be filled with powders. So you have to remove that powder with the help of exhaust. This system will exhaust, suck all the powder and put it into this container through a different chamber, right? And one particular, with the help of this 3D printer, they have printed around 2, 3, 4 by 3, 12 components in a single plate. Okay, so 12 components in a single plate with the help of multiple lasers, not a single laser, multiple. So not only 12, it is 4 by 4, 16. Okay. So once the powder removed inside the chamber, this is chamber, what you have seen earlier. Once removed, you have to remove with the help of your hand. Okay. So similarly, what are the types of material you can build with the EOS? Say, for example, this is a Conflex heat exchanger. Conflex is a very big company. They are into the supply of the heat exchanger to the companies. For that company, this EOS machine made a trial of this heat exchanger. So this is basically aluminum, silicon, manganese, and this has got the tensile strength, the UTS of 460, yield strength is around 255, and the elongation at break is 5%. These are all the common technology, and a complex shape with aluminum also possible with the help of 3D printer. So this is titanium. Okay. So for aerospace application, this labor company from European company, they are into this manufacturing of this kind of different shape. This is basically titanium TI6, okay, of grade 5. This TI6 is many people know commonly. It has got good mechanical and corrosion resistance property, and also low specific weight and biocompatibility. Okay, that is why this TI64 is famous, because of this biocompatibility. And the chemical composition are given here. The ultimate strength is definitely higher because of the titanium alloy. Whereas aluminum, you could be able to see here only 460. If you want more strength, you have to go for titanium. Okay, yield strength. But this one is not biocompatible. Okay, and this is nickel alloy, which is frequently used in aerospace applications. And this nickel alloy can be printed with. I got it from EOS people, and this is a burner which is used in aerospace, and this kind of burner can be printed in all the 4 machines, EOS machines available. Okay, so the property again, this nickel alloy also having the property similar to titanium. Here it is 1080, here it is 1020, more or less 10% deviation. And why this nickel alloy is used? This has got a good tensile property, and higher fatigue creep structure is also more, and it is used for high temperature application for gas turbine and instrumentation parts and chemical industries, process industries. Okay, so complicated shape like this, it is very impossible to go with when you go for conventional type of machining. It will take more time, but when you use 3D printer, you can get intricate shapes. That is the advantage, right? And this one is also possible now with 3D printing, case hardened steel. So any student or faculty they want, they can go for case hardened steel, and this has got even higher ultimate tensile strength, and when compared to titanium and this other alloys, nickel alloy. And this case hardened steel is contain good hardenability, hardness it can withstand, and also the advantage is good wear resistance. And yeah, so this one is I have to thank the GE people for allowing me to show this to you people. And say, for example, in a single plate, so many complicated shapes I have. I'm showing here. Any kind of complicated shape with the materials what I have shown earlier can be printed. just it is printed in a single plate just to give an experience how difficult component can be made. Okay, so you cannot make the component just like that, and you have to go for some structure, support structure. One of the student also asked what is the support structure. That also I will discuss in the coming slide. So what you are seeing here, complicated shapes of many, for understanding purpose it was done. You can print any size. Okay. Only thing is you have to carefully select the machine bed size. Okay. Now 500 also available. You see here, this is one of the typical example. A complicated shape on the right side picture, you could be able to see. Actual requirement is only this one, this part, this part, this part. Okay, and these portions are called the support structure. You cannot build these portions without this support structure. What you got to do, this support structure, you have to just cut and remove all these things. You got to remove. See, this kind of porosity looks like structures are called as support structure. So selecting the support structure is a typical thing you have to consider when you go for 3D printing. And without this support structure, you cannot build this much height component. Okay. So there are different support structure dimensions, and selection also possible. According to your requirement, you have to select. Okay. And you can able to see here, the actual component is these portions, bottom, this pipe, everything. And these are all support structures. Just for understanding purpose, I am showing all these things. So once the component got ready, you have to remove. You have to remove either with the help of cutting plier or with the simple machines. You have to remove, and the final shape will be available. So this process is called as post-processing. Say, for example, after removing, you may need a finish on this external part. So for that, you have to go for some machining, fine finishing operation. Okay, that is called as post-processing. Okay. So these two components you see, if you want to make a circular hole, you cannot make just like that. So if you want to make a circular hole, you have to create some structure that is called as that may be of different size and shape, and this structure is called a support structure. Okay, so once the product finished, it will be removed. See how complicated shapes are produced. So these are all the live component, not taken from the web. Okay, these are all original component printed. You could be able to see a complex structure of a cube with a minute hole, micron level hole, also possible. And this is a turbofan model, and it is also possible. See here, one more view of support structure. Say, for example, if I want to make this portion, I cannot print directly. So I need this support structure. Finally, I have to remove this portion. Yeah. So please, all students and some of the participants, please go to this website, and vlabs.ac.in. Okay, where you can find a simulation of this selective laser sintering process, and you could be able to see this simulation. And not only this process, it is for electrical, mechanical, mechatronics people, and ECE, for all branches. They have given simulation. Okay, just to visit this vlabs.ac.in. It is free, developed by our Ministry of Higher Education, and you can find that simulation demo. It will be of interesting. So with this, I'm just closing my session. Otherwise, it will be boring. if I go deep into technical talk. And thank you for listening. I especially thank Dr. Pritima Madam, Professor SKCT, and Dr. G. Veerappan, and other organizers and coordinators. And also I thank for your invitation. Maybe in future, if time comes, I will share some of my practical experience also. So with this, I close. I shared one video to the Pratima Madam. Maybe she may play that after the end of this. So if you have any questions or anything, I'm ready to answer.
Sir, good morning, sir. So, good afternoon.
Yes, sir.
Sir, myself, Veerappan. I have a
Yes.
clarification regarding the support structures. Mostly we use wax-based materials. Apart from any other materials we are using for building the support structures, sir.
No, that is for plastic 3D printing, what you are saying, right?
Yes, sir.
And mostly we also used the same filament material as material while we did our samples.
Okay, sir.
Say, for example, we use dual jet 3D printer. We also developed one 3D printer that has two heads.
Okay.
So one head we gave PLA, and another one ABS. For support structure, we used PLA. For original structure, we used ABS to get high strength. So like that, you can change the material also.
Okay, sir. Thank you, sir.
Okay.
Sir,
Ah.
how to choose a proper filament based on our requirements, sir? What are the factors that we should keep in our mind?
No, copper 3D printer is available with the EOS. You cannot print from copper wire like ABS or PLA wire. Okay? For copper powder, you have to take. Okay? From copper powder, that will be exposed to the laser, and according to your design, you will get your final shape. It is not something similar to ABS or PLA plastic wire. It is not like copper wire. So whatever I discussed in copper is it is used for metal 3D printers.
Okay, sir. Sir, can we perform 3D printing operation in open atmosphere?
No. You have to go for a controlled atmosphere. Either it may be argon, or sometimes they may go with nitrogen also. Okay, so in that controlled atmosphere only you have to print. So those argon and nitrogen gas will be supported by the separate pumping station, which is available outside the room of the 3D printer. Due to this limitation and other hazardous, those argon plant will not be near to your 3D printer. Okay, that will come from a pipe from the other room. The highest, okay.
Okay, sir. Sir, is there any availability of metal 3D printing institutions for research purposes?
Yes, it is available. If you want to go with, so you are located in Coimbatore, and if you want, you can get help from NIT Trichy. So they have recently they bought a new 3D printer where you cannot print titanium and others. You can easily print this low grade steel and aluminum.
Okay, sir.
And,
sir, will they permit students to work
yeah,
on
yeah.
them?
The students they will permit, and I will give you the reference with your coordinator, Pritipa Madam.
Sure, sir. Thank you, sir.
So I'm closely working with that laboratory also. And any of your students willing, they can come and do
Okay,
part of
sir.
their project also.
Yes, sir.
So any questions in the chat box? Voice is not clear. How do you control the laser beam? Yeah, one is Marisami laser beam control for particular say for example, now many 3D printers, they are allowing the other makers powder. Earlier it was not like that. Say for example, if I purchased EOS machine, I have to use the powder only given by EOS. Say for example, if I want to use titanium powder, the titanium powder I have to buy it only from EOS, not from any other company. Okay, and that is one thing. And now many companies like Mitsubishi and many Chinese companies, they are allowing other company powders also. So they will give you for their powder what is the laser beam you have to select. So initially you have to go for trial and error method. During the technical specification, I discussed the laser beam. Power supply and 400 watts. Okay, that's EOS 290 using only 400 watts powder. How can be controlled the temperature of the powder? Yeah, temperature, I don't understand from this question. Normally, high heat will be normally whatever the product you are going to what you designed, that portion will be exposed to the laser. Okay, the remaining portion will not be exposed to the laser. That portion, remaining portion will remain as a powder. That is what you have seen in my slide. When you remove the printed material from your from the chamber, you have to first remove the excess powder which is surrounded by your printed material. Then you have to remove. So temperature it can withstand accordingly. It is designed for that. What are the other materials can be used for? Yeah, I answered for this, Professor. Any other thing?
Excuse me, sir.
Yes.
Sir, shall I play the video that you have sent?
Yes, yes.
Okay, sir.
Knowing your way around Docker and its capabilities is a must for high-quality production.
It's a small video.
Okay,
Just
sir.
to show how the printing is happening.
Yes, sir. Yes. Sir, shall we wind up, sir?
Yes, if there are no more questions, we can wind up.
No, sir. No questions, sir. Thank you, sir, for sharing your points about additive manufacturing and 3D printing. This gave us an interest to research and achieve something innovative in this. Hope all of us have got a clear understanding about this informative session. Thank you, sir.
Okay. Thank you very much for listening, and also I thank finally the coordinators. Thank you very much.
Thank you, sir.
Thank you, sir.
Dear participants, the next session will be on 1:30. Bye.
Hello.
Sir, what, sir?